Hey everyone, welcome to another session in CeerazzleDazzle Physics. In today's session we're going to be talking about voltage. So question 1, how do we measure voltage in a circuit? The way we measure voltage is by using a voltmeter. So to measure the voltage we use a voltmeter. The symbol for a voltmeter is going to be the following. It's going to be a circle, capital V, and two lines on either side to represent the wires. How do I insert it into the diagram? I'm going to place it around the component I'm testing. So I'm going to place it, around the filament bulb here. So right now the voltmeter will measure the voltage across the filament bulb. Easy stuff. So from the top, to measure the voltage I use a voltmeter and I place it in parallel across the component. Now scrolling down, the voltage in a series circuit. So to solve all these problems, all you've got to know is one simple rule. It is that the total voltage going in must be equal to the total voltage coming out in one loop. So once again, the total voltage going in, total voltage in should be equal to the total voltage out in one loop. It's really important, guys. It's only in one loop that this works. There's a total voltage going in equals the total voltage coming out. So put that into context. Let's say I have 10 volts coming in from this battery here. So you know the rule is this. In one complete loop, whatever voltage goes in equals to the voltage coming out. So here is my loop. So if I have 10 volts coming in, and I know that must be the same as the voltage coming out, and I've got one component, it must be 10 volts delivered here. Yeah? Oops, let's just move that. Okay, it's getting a bit dirty. There we go, 10 volts. Now, the next diagram, let's just say I also have 10 volts coming in, and this is my loop. So if I pick up 10 volts from the battery, how much will I deposit across each one? I've got two components, so I must share the voltage out across the components. So I'm sharing the voltage out across the components. Therefore, it's going to be 5 volts here and 5 volts there. So 10 volts come in, dropping off 5, and we're back to 0 before we get to the cell. And the last one, let's go. So we're going to have, this is my loop once again. Now I've got 10 volts coming in. So but I've got 3 different components now. 3 different components. No, sorry, they're the same component. Therefore, I have to divide the 10 volts by 3. So this one will get 3.3 volts. The other one will also get 3.3 volts. And the last one will get 3.3 volts. As you can see, the total voltage in equals the total voltage out in each loop. Easy stuff. Now, that's for a series circuit. What happens if we have a parallel circuit? So let's scroll down. Voltage in a parallel circuit, we still have the same rule. It is going to be the total voltage in must be equal to the total voltage out. Notice I'm becoming a bit lazy. V in means voltage in, V out means voltage out. So therefore, in this diagram, let's do the first one. Let's say I have 10 volts coming in. Right, so common misconceptions, a lot of kids think it's going to be, oh, it's 5 there and 5 there. No, that's not the case, because that's not the loop. So this is our first loop. So if I pick up 10 volts here, how much will I deposit? So in one loop, this will also be 10 volts. Easy stuff. Now, what happens if I actually have the next loop then? Let's do the next loop. So if I have 10 volts coming in, this is my second loop. This one will also be, yes, 10 volts. Because in one loop, the voltage in equals to the voltage out. Superb stuff. Now, what about the one on the right-hand side? Let's do a bit of, let's add some more numbers. Let's go, 10 volts going in. So this is the first loop. So 10 volts come in. This one will also be 10 volts. Second loop, let's go. 10 volts come in. Therefore, I'm dropping off also 10 volts. And the next one, let's go, I have to erase some of them. There we go, last one. If I have 10 volts coming in, this is my loop. Once again, I only have one component. I'm dropping off 10 volts. Easy stuff. Scrolling down, we're going to test our understanding. Yeah? So let's test our understanding. So we know that in each case, the total voltage going in equals the total voltage coming out. Now, let's check if we actually have learnt something in today's lesson. So, can you work out what the voltage is for all the values in red? So what will they be? I'm going to give you a minute. Okay. You can pause the video, do what you want. Right. You know it's 10 volts going in and 3 volts are dropped across this resistor. So how much must be dropped off across here? Yes, you are right. This one will be 7 volts. Why? Because 7 plus 3 makes it 10. Yes, the total voltage going in equals the total voltage coming out. Right, the next diagram is a bit harder, but look. You know it's 9 volts coming in. Oops, that's the wrong pen. Let's go back. Undo. 9 volts coming in. And how much will I drop off across this bulb? We can do this one first. 9 volts coming in. This one will be 9 volts coming out. Right, that's one loop. What about the next loop? We also know 9 volts coming in, and I've got this loop now, but there's 3 components, so I must share the 9 into 3 separate components. So it's going to be shared across 3 separate components. It's going to be 3 volts, 3 volts, and 3 volts here. Easy stuff. Now the last one. Let's go. 9 volts coming in, and I'm already dropping 2 across this component here. So how much will the bulb take? Well, I can do simple maths. 9 volts minus 2 volts, this one is going to be 7 volts over here. Easy stuff. Right, so summarize the learning today. Summary. Voltage is measured using a voltmeter, and here is the symbol of a voltmeter. Circle capital V. Next of all, the voltmeter is connected in parallel across the component. In series circuits, the voltage is shared across the components. So if you have 10 volts in and 2 components, it's going to be shared maybe 5 volts and 5 volts each. And last of all, in any loop, the total voltage in is equal to the total voltage out. Let's highlight some key terms here. So voltmeter reading over here, voltmeter is connected in parallel across the component, and the total voltage in is equal to the total voltage coming out in one loop. And that's it for today. I shall see you next time. Goodbye.